I thought there was a bit of explanation missing from the course, and I had to do an additional research, and I found this really good explanation on Cisco community forums. I will provide a link in the description, but this really helped me to understand how the shared tree joins work, as well as how the source joins or new sources introducing into the multicast domain work. So for the shared tree joins, this happens when a new receiver joins the multicast tree, right? So receiver in this case is typically like a computer, right? And the computer, what the first step which it does, it sends an IGMP message, right? So IGMP message is sent to the gateway, to our last hop router, which is also the designated router. It will receive the IGMP message, and then it will send the star comma G joins, and G is for this specific group which the receiver needs to join. It will send it upstream towards a rendezvous point. So it knows the IP address of the rendezvous point. It can look up for this IP address in its own unicast routing table. It will understand which way rendezvous point is located, and it will basically send this join message out of this interface. Okay, and this way, this message will travel upstream all the way towards the rendezvous point, hop by hop, and each router on their way will learn, okay, I need to start forwarding multicast traffic for this specific group G. So each router will know this, and this will reach the rendezvous point, and then rendezvous point will start forwarding traffic towards this branch, right? And because each router learned this information, they will also be forwarding traffic to towards the receiver. Okay. One other thing I want to talk about is the PIM Sparse Mode SPT switchover, and SPT here stands for shortest path tree. And just to pick up from our previous example, once the receiver has joined the group, it is happily receiving traffic from the rendezvous point, right? But in order for this rendezvous point to get this traffic in the first place, it will need to be sent from the source to the rendezvous point, and there is a specific branch which needs to be built for that, right? Is there a possibility in this particular network, in this example, to build a better path between this specific source and this specific receiver? Probably yes, because traffic could go like that. Maybe it is the more optimal path. But the question is whether it is possible to do that and switch over to this alternate better path. And actually, the SPT switchover does exactly that. The first thing which needs to be done, this router on the receiver side, it needs to make a decision like, do I need to do this switchover? And there is no any kind of policies, I understand, within the protocol itself, but basically, typically the decision would be made on the volume of traffic which receiver receives as part of this source and source group multicast translation. So by default on Cisco routers, this threshold is actually 0, which means once receiver has joined this group and it started receiving the traffic, it will perform the switchover immediately. All right. The way it works, it starts from actually knowing who is the source for this traffic, because before joining this group, this router did not know what is the exact source. It was like star comma G rather than S comma G join, right? So once it knows the source, it actually knows the source IP address, and what this router can do, it can resolve this source IP address through its unicast routing table. So what it does, it sends back upstream these SG joins messages, right? And they will be propagated through the routers according to the unicast routing towards this IP address. And again, because this is the join messages, each router on the way will make sure it joins this particular source and group pair. And eventually it will reach this source. And this way, a entirely new branch will be built for this receiver. All right? The next thing which will happen, this receiver will send the special sgrp bit prune messages upstream towards the rendezvous point. So this way and this way, effectively telling the rendezvous point, hey, I do not need to receive this traffic from you anymore. Why does it need this traffic? Because it has already established the direct path from the source to itself. And this way, the RP, the rendezvous point, will stop sending traffic towards this receiver. And at this point, if this rendezvous point doesn't have any other receivers for this SG pair, it will also send back the prune messages to for following its own branch of the tree, which will reach eventually the source router, source gateway, and it will cut off the flow of the multicast traffic towards itself because it doesn't need this traffic anymore, and it does not because it has no one to forward this traffic to. And this way we have the most efficient, the most possibly efficient path for this traffic from flowing from source first hop router towards the receiver last hop router directly. And this one is about how a new sender joins an existing multicast group. Okay. So again, step by step, we have a new source or sender being introduced to the network. This could be a computer here. This computer just starts to send multicast traffic for a certain group G, right? So this designated router for this network, which is also the first hop router, hears this multicast traffic, understands it doesn't have this group served yet, right? And what it does, it takes this multicast traffic and it encapsulates it into a PIM register messages, which are then sent over unicast directly to the rendezvous point, right? So again, these multicast packets, they are being sent to rendezvous point kind of directly over sort of unicast tunnel. It's not really a tunnel, it's just encapsulated into a unicast traffic. So when this rendezvous point receives this traffic, it does two things, right? First thing it does, it decapsulates the multicast traffic from this source and sends it down the line, right? Whoever is subscribed for this multicast group G, it will just serve this. And one another thing it does, it understands, hey, I do not yet have a proper way of receiving this group G traffic. And it will take a look at this source, who is the new source, and it will start sending the PIM join messages for this group and for this source. And of course, because it knows the source address, it can understand which which direction the source is based on its own unicast routing table, and sends these join messages over here. And then again, similarly to the previous case, the hop by hop, each router on this branch will resend these join messages, and they will learn, okay, we now need to join this, and we need to be part of this branch of the shared tree for this source and this group, right? Okay, so, and this way, this branch is formed, right? And then the next thing which will start happening, this multicast traffic will start going the multicast way towards the rendezvous point. So at this stage, the multicast traffic is just reaching rendezvous, starts reaching rendezvous point over the normal multicast routing. And once rendezvous point starts hearing this group, right, with the normal multicast flow, it will send back to the designated router a unicast message over PIM, which is called register stop. It does not need to keep receiving those messages in this encapsulated form, right? So it sends back the register stop, okay, which stops this stops this encapsulated traffic being sent over unicast to it, and then it continues receiving this traffic over the normal multicast, and then pretty much it keeps working normally.